Hi everyone, I'm Dr.M and welcome to our course, Thermodynamics.
From our previous lesson, we discussed that heat capacity of a substance is the amount of energy required to raise the temperature of the substance by 1 degree Celsius. We also discussed the specific heat of a substance, which is the energy required to raise 1 gram of a substance by 1 degree Celsius. Heat, temperature, and heat capacity are all related by the equation, wherein Q is the amount of heat exchanged in the reaction, and it is equal to the heat capacity of the substance C multiplied by the change in the temperature for that substance, or more practically, the heat exchange is equal to the specific heat of the substance times the grams of the substance present times the change in temperature. We can learn about heat transfer using a process called calorimetry. Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. It is also the measurement of the quantity of heat exchanged. By knowing the change in heat, it can be determined whether or not the reaction is exothermic or endothermic. Heat as a form of energy can neither be created nor destroyed. Heat flows from one object to another. This concept of conservation of energy leads to determination of the specific heat capacity of substances. In determining the specific heat capacity of an object, it is necessary to measure the mass of the object, the change in temperature, and lastly, the amount of energy transfer as heat. If a hot material is placed in an insulated container filled with water, the heat released by the hot material will be absorbed by the water. There will be a small amount of heat energy absorbed by the container, but the effect is negligible that it can be ignored in this discussion. The heat released by the hot material or the heat lost will be equal to the heat absorbed by the water or heat gain. Heat released by hot substance is equal to heat absorbed by water, or heat lost by the hot material is equal to heat gained by water. A general equation can be written as follows. Negative heat lost by hotter object is equal to heat gain of colder object. Or negative delta Q lost is equals to delta Q gain. Since delta Q is equals to mc multiplied by delta T, then mc delta T loss is equals to mc delta T gain, where m is the mass for hot or cold object, c is for the specific heat capacity of the object, T sub f is the final temperature, and T sub I is the initial temperature. A device for measuring the heat developed during a mechanical, electrical, or chemical reaction and for calculating the heat capacity of the materials is known as calorimeter. A calorimeter usually contains a thermometer to measure the final temperature when the materials are in thermal equilibrium. As here, make sure that the energy is distributed uniformly. Now let us discuss melting and freezing. When solids are heated, they become liquid. This change in phase is called melting. For pure substances, melting happens at a fixed temperature, which is known as the melting point. The latent heat of fusion of the substance is the heat absorbed to melt solids into liquids without the change in temperature. The heat released during solidification without the change in temperature. The freezing or solidification is the opposite process of melting. Freezing or solidification is turning liquid into its solid state. A pure substance will freeze or solidify at fixed temperature, known as the freezing point. In addition, the freezing point is the same as the melting point of any substance. When a pure liquid is heated continuously, it changes to gas or vapor at a fixed or constant temperature known as boiling point. The reverse of boiling point is known as condensation. Condensation is defined as the change of phase of vapor or gas into liquid without a change in temperature. The heat that is absorbed by the substance during boiling without any change in temperature is called latent heat of vaporization. It is also equal to the amount of heat released during condensation for the same amount of substance. Evaporation is a cooling process. It also requires heat. Boiling and evaporation are two different concepts. Even though they both involve phase change from liquid to gas, the table below summarizes the differences between boiling and evaporation. From the table, we can see that for evaporation, it occurs at any temperature, while boiling, it happens at a fixed temperature. For evaporation, heat comes from the surroundings. For boiling, heat given comes from an energy source. For evaporation, temperature may vary. However, for boiling, temperature remains the same throughout the process. For evaporation, it is a slow process. However, for boiling point, it is a quick process. For evaporation, no bubbles are formed. For boiling, bubbles are produced. And last, for evaporation, it takes place on the surface of the liquid. And for boiling, it takes place within the liquid. Now, there are several factors affecting the rate of evaporation. These are as follows. Number 1, temperature. Evaporation occurs at any temperature. Increasing the temperature increases the kinetic energy of the molecule, making it more energetic to escape. Next is humidity of the surrounding air. Humidity is the amount of water vapor in the air. The more water vapor in the air, the harder it is for liquid molecules to evaporate. Thus, higher humidity means a slower rate of evaporation. Next is the surface area of the liquid. Evaporation only takes place at the surface. Increasing the surface area means more molecules can escape to the atmosphere, thus increasing the rate of evaporation. Next is the movement of air above the liquid. Blowing air on the surface of the liquid immediately removes evaporating liquid as soon as they escape. This increases the rate of evaporation. The next factor is pressure. Lower atmospheric pressure means fewer particles in the atmosphere. The less crowded the atmosphere means more opportunities for the escaping molecules, thus increasing the rate of evaporation. And last, the nature of the liquid. Substances with a lower boiling point have higher rates of evaporation. That's all from now. Thank you and stay safe.